Good day people, welcome back to the next lesson. There's a next one there. We have a lamina, it's got a triangular bottom, rectangular, and a semicircular cutout. What's the first thing we do? We divide it up into shapes that we know, into shapes that I showed you earlier, shapes like this of known geometric properties. Okay, so we divide it into those shapes over there. Right, I am going to, I'm going to divide this up into triangle, like so. Okay, and there we have a triangle, we have a rectangle, and we have a semicircular cutout. Okay, and before we start, we need to work at the dimension from there to there. Okay, and it's 350 plus 350 plus 120 plus 30 minus 200. So that bit there, 300. Okay, right. So that's 300 there. Okay, let's make a start. So I'm going to call this element 1. Element 1, element 2, and element 3. Okay. Alright, I'm going to go in order, so I'm going to do the calculation. I'm going to use the length of this. You can use a table or by calculation. Alright, I'm going to say bar y. Okay. Let's choose a point A. I'm going to choose, let's say point A over here. Okay. I'm going to say the sum. Oh, what's wrong with me? Taking moments. Bar y is equal to the sum of the area times y over the total area at element 1. What's its dimensions? 200 by 180. Nice and easy now. So it's 200 times 180 times. What's y? Y is the distance from the centroid of the element. It's sitting somewhere over there. So how far from there to there? It's 100. Plus, why plus? Because it's the sum of. Right, we have a triangle. What's the formula for the area? Half base times that, so it's half times 300 times 180 times. Have you got your thinking caps on? The centroid for this triangle is sitting somewhere over here. It's 1/3 from the base up and 1/3 from the base the other way. That's where it's sitting. Center of the triangle there. So what's y? Y is the distance. I made a mistake here. Oh man, that's wrong, yeah? That's wrong. That's not right. I used the horizontal distance. It is that. That is 100. Yeah, sorry about that. 100. Go 100 because we. Oh man, not right. Still wrong. It's the distance from the centroid down to point A, which is 90. 180 over 2 is 90. Sorry about that. Right, triangle, half base times that. And how far is it from there to there? It's 1/3 of that height. So it's 180 over 3, so it's 60. Right, now we have a cutout. It's going to be a minus. So if it's cut out, it's take away. Okay? Not the ones you get at the shops, at the fish shop. No, not that takeaway. It's minus. Okay. Right. So what's the formula for the area of a semicircle? It's half pi r squared. It's half pi times r squared. And what's the radius? The radius is 60. It's half pi r squared times. Right. The centroid for the semicircle is sitting over there. Okay. What's the formula for that bit from a table? If I flash back to our table, here it is. 4r over 3 pi. There we go. So that there is 4r over 3 pi. I'm going to work at that. It is 4 times 60. It's 240. 240 divided by 3 pi. 3 times pi. 25.46. So it's 25.46 millimeters. So the distance from there to there is 25.46. Okay. So there's our area for the circle. And I'm looking at y. What's y? Y is the distance from the center to the point we're taking moments about, which is from there to there, which is 4 over 3 pi, 25.46. Are there any more? There's no more. No, so now we can continue. So now, all of that divided by the total area. So it's 200 times 180 plus half base times height minus half pi times r squared. I'm going to squeeze it in here, and of course we must get millimeters. So while I pause that, let's work it out, get a nice answer to two places. Okay people, I got it right there. I get 82.24, 82.24, that's millimeters. Okay, why? Because it's the distance. Right, so what does that mean? That is the distance from the bottommost fibers up to where the x-axis is sitting. Okay, that's what it means. If I just do that there, from there to there, that's half is up 90, so it's about sitting just over there somewhere. Okay, so that's the x-axis. That's for y. You don't need to draw it in. I'm just pointing it at you so you know what it is while we're working it out. Okay. The distance from the bottommost fibers to where the x-axis is sitting. Have we answered the question fully? No, not yet. We know how far, but we don't know how far from the left, from the right to the left, with the vertical y axis sitting. We're going to do that now. Okay. So we say bar x is equal to the sum of the area times x over the total area, which we already know. Right, element 1, 200 by 180. That stays the same, 200 by 180. What's x? X is the distance from the centroid to the point we take in moment area is about, and how much is it? It's 200 over 2, so it's 100. Plus area of a triangle of base times height times. What's x? X is the distance from the centroid of the element to the point we take in moments about. So it's the distance all the way from there up to there. Yep. It's not 300 over 3. It's 300 over 3 plus that bit, plus that bit, plus that bit. Okay, so it's 300 over 3 is 100 plus 200, so it's 300. Minus 1 minus, because it's a cutout. What's the area for a semicircle? It's half pi r squared of pi times 60 squared times. Right, what's x for the semicircle? X is the distance from the centroid of the element to the line we've taken moments about. So it is 60 plus 60, so it's 90. Divided by the total area, which I worked out earlier, which is this over here, is 57345.13. And that's going to give me an answer in millimeters. I'm going to pause it for a second to work out the answer. And the answer I get is 105.15, which you should have gotten to. Hopefully I didn't make a mistake. There we go. And what is that? That is the horizontal distance from A towards the left to the vertical y-y axis. That's 195. That's 200. So it's sitting just to the right of like so. Capital Y, capital Y. Don't need to draw this in. I'm just drawing it in so you can see what it is. Okay, people, there we worked it out. The question was, there's the cross section. There we had a triangle with a rectangle, and we had a semicircular cutout. And we used all the bits from the tables, from the tables I gave you, that over there, to find that over there, y is d over 2, y is d over 3, and y is 4 over 3 pi. Using that there, because whenever we have a cutout, it's always minus. We treat it as a minus, and that's the bar y and bar x about that particular point for this section. Okay, people, thank you very much, and I will see you in the next video.